3D integration is the heart of Novartis' fabrication expertise. Our cornerstone technology module is the Direct Bond Interconnect, or DBI, demonstrated here forming a bonded pair of two wafers, an analog or sensor wafer and a digital or CMOS wafer. The surfaces of both the analog and digital wafers must be similarly prepared and controlled with a high degree of precision. Silicon dioxide is conformally deposited and then planarized to tight tolerance. Photolithography is used to pattern the first via. Then the pattern is etched. The resulting via features are filled with copper and planarized again to create a standoff from the bond pads on the wafer to the subsequent routing and bond layers. Next, silicon nitride and silicon dioxide are deposited using plasma-enhanced chemical vapor deposition, or CVD, before the dielectric layers are patterned, etched, filled and planarized, just like the previous step, except now a routing layer that carries signal, power and ground is formed. These steps are then repeated to form the direct bond interconnect layer that will connect to the routing layer and the mating DBI layer on the second wafer. After each wafer is sufficiently planarized, the analog wafer requires an edge trim to ensure structural integrity during the thinning process. The DBI layer is protected with photoresist during this step. The photoresist is subsequently stripped from the front side of the analog wafer, and both wafer surfaces are then plasma activated and cleaned. Then the front sides of wafer 1 and wafer 2 are bonded together to form the bonded pair. Through silicon vias, fabricated in the backside of the analog wafer, must be revealed by a thinning process. The bonded pair is now ready for photolithography and etching to pattern the openings and prepare bond pads for wire bonding or bumping done in later packaging operations. Alternatively, in order to continue building up a multi-wafer stack, any remaining silicon is removed with wet processing or plasma processing, leaving a small protrusion of the TSVs on the backside of the analog wafer's surface. Silicon dioxide can be deposited to cover the protrusions, and a final CMP reveals the metal-filled TSVs. Routing and via layers can be added as required to prepare the bonded pair to be connected to additional wafers in the stack. From integrating sensors onto CMOS or 3/5s to silicon, Novartis' commercial 3D integration capabilities can accelerate your innovation through development to production in one stop. Novartis Technologies, better performance through smarter integration.